All
There
right.
you go.
So advent of code. Um, I think it probably takes this one guy who runs advent of code all year to write the 25 two-part programming problems that make up the advent of code. Um, it's an advent calendar, so it starts on December 1st and it goes until December 25th. And at midnight on each of those days, uh, he opens up a new problem. Um, it is open to anyone. They can solve the problem in any language they want. You do have to log in. To log in, I think you have to use your GitHub account. Once you log in, you will see the same problem description that everyone sees, but the input data, the problem set that is provided for you when you say there's a download button for you to get the data for that day, and it applies to both problems of the day. The data you get is unique to you. So you can't share your answer with other people. Um, Let me actually um, show you the advent. This is too small. Let me grow it. And if I go to the About page, uh, this is at adventofcode.com, and you can get to it. Um, it's very important not to make anything that looks like this or that includes the actual data that you were given, or copies any part of the problem description. And we were careful to repeat those rules in our README for our repo and to not do any of those things ourselves. Um, in each puzzle, and here's an example of puzzle number one. In each example, there's a part one, and you answer it in a text field. This was my answer. It's different from everybody else's. And once you solve part one correctly, then you are presented with a part two that uses the same data set. The problems generally start easy and get harder and harder. Um, I've never gotten very far because I never find the time. I am trying to do them all this time because I'm trying to use them to learn Rust. Um, our event here at Mug is that we have as many people as we reasonably can in as many different languages as they can use write their solutions to the day one problems, day one and day two. Um, so we have put all of that into a publicly available, you can't commit to it, um, but you can fork it and send us a pull request. Um, this repo has a README at the top level, and then it has folders for each different language. And we've done a ton of different languages. And then inside each language folder, let me make this screen big. Sorry about that. There is a folder with the GitHub name of the person whose solution has been submitted. So here in the Python folder is the first thing I'm going to show you. Let me go back to what day one, part one was. Day one, part one is that you get a pair of lists. It's a text file, and the two lists are arranged in columns. So a left column and a right column. And essentially, uh, if you step through the story problem of day one, what you figure out you have to do is you have to read in the lists, make them be separate objects of some kind, sort them from lowest to highest. Um, at least that's what they say in the problem. But they have to be paired up, so they're sorted, each of them on their own. And you have to find the absolute value of the differences for each row. So the smallest left minus the smallest right, the absolute value of that, and then the second row, and then the third row. And what you've made is a whole new list, and the answer to day one, part one, is the sum of that list. So day one is pretty easy, and I am going to show you what I think is an easy solution. I actually solved this in maybe 6 languages. I'm not going to show all of them. I think a couple of them are very interesting. And each time I solved the problem in exactly the same way. So with the very first one, which I think is probably almost the simplest, I'm going to show you how I solved it. And then after that, I'm just going to show you why a specific language makes a difference. So here's my Python day one folder. I implemented it in Python in 4 different ways, but the ways, each one builds on the one previous. The first thing I did was a simple implementation, the simplest thing you could reasonably do. It doesn't take any parameters or do any argument parsing. It reads from standard in, it solves the problem and prints the output. There's no virtual environment. It doesn't include any other Python packages. It doesn't use anything outside of the standard library. In all of my solutions, almost, I made 3 functions. I made one called read the 2 lists. I made one called distance between the 2 lists. The distance between the 2 lists is essentially part 1 of day 1. And similarity score, that is essentially part 2 of day 1. And then my main, or whatever I have, reads in the 2 lists and then calls those 2 functions and prints out the answer. Reading in the 2 lists in Python is fairly easy. Down here in my main section, I call read the 2 lists on standard in. So read the 2 lists takes 1 parameter input, and that's a file that's already opened. Standard in is ready to go. You don't need to open it or anything. And if you use an iterator on standard in, you will get out the contents 1 line at a time. And if you take a line and split it on white space, that will return all of the fields. I happen to know that the input is all well formed, that they're all separated by white space, and it will always return exactly 2 values. So if I split the line, I will get back the left side and the right side. I will use the int converter to turn that well-formed string into an integer and append it onto, I've built a left list here that starts empty and a right list. a thing about this Python that is different from Python you might ordinarily see is that I have used type annotations everywhere. I think types are a good thing, and even though Python is easier without types, I like to add them because it lets you write bigger programs. So read the two lists starts with a text file full of numbers and returns two Python lists full of actual integers. I put comments, lots of comments, so you can see that this function, which is part one, actually is pretty easy. It's calculating the total distance. Zip, the lists aren't sorted yet because we don't know how they came in the file. And I don't want to sort them for the caller because who knows what the caller is going to do with them. The Python function sorted of a list returns a brand new list that is sorted. Zip takes any number of lists and squashes them together into one list of tuples. Because I said two different lists here, I will get tuples out of it one at a time. So X and Y are the things I got out of the tuple. That's the first two values in this zipped list. That is row one. So I get the absolute value of the left side minus the right side, and I add that into the distance. And at the end, I return the distance. It's a super simple function. And you can see what I do once I know the answer. Python F strings do substitution inside curly braces. So I can just call my function with left and right, the two lists that I made. Similarity score is a little more complicated. What similarity score wants you to do is add up the sum of each value in the left list times the number of times that value, the left list value, appears in the right list. And that might be 0. Maybe that left value never happens in the right list. It might be 10. Who knows what it could be? There is a special built-in kind of dictionary in Python called a counter. Here's where I import it from collections import counter. And what a counter does is it builds a dictionary of when you give it a list, and here I'm giving it the right list, the same right list you've seen everywhere else. It builds a dictionary where the key is the value from the right list, and the value in the dictionary is the number of times that key appears in that list. So right counts is a dictionary, and all I have to do is for each value in the left list, see how many times it appears in the right list, multiply it by the left list value, and add it into similarity. It sounds hard, but it's actually easy. So this is the entire day one solution in what I think is almost the simplest form. I am going to show you one form that I think is simpler because I think it's interesting. But let me tell you what these what the difference is between these four implementations. The first implementation was simple. No packages, no nothing, no tests. It was what you would write off the top of your head. This day two version actually has tests, and the tests that it has use the data. If I go back to the day one problem, see this is 3, 4, 4, 3, 2, 5. If I look at my test data, 3, 4, 4, 3,
Mhm.
2, 5, I am using the sample input from the problem. It is okay for us to share that according to the About page. And I know what the answers for those sampled pieces of data are because the problem description gives the answer for those. So I write a test for the distance function using those two sample lists and for the similarity score function. So that is the main difference between version 1 and version 2. Version 2 is almost exactly the same project, except that it has tests and it's created by UV. Version 3 actually splits the project up into packages. In Python, when you're writing a big project, you will make sure to divide things into collections of tools that all work together. So my day one is very simple now. It just has a main. And I've used a library here called Typer so that I can actually parse the command line. I'm not going to show you this running, but I will show you the package that I wrote. The package is called list tools, and it includes those two main functions that I wrote, distance between the two lists and similarity score. They're the exact same code as before, but now they're in a new place. So that's the difference between version 2 and version 3. And finally, version 4, I learned something new um, a few weeks ago, and that new thing was how to implement a Python package in Rust instead of in Python. So inside this list tools package, I actually export these Python functions. Read the two lists, except it's written in Rust, and Rust takes a lot more lines of code than Python does. Distance between the two lists and similarity score. And then to define this module, I have to export those functions. I don't want to explain this piece of Rust, but I want you to know that because this repo is public, you can just look at it, you can clone it, download it, get into the code and use the code yourself. To understand whatever part of it you want, you can do that. I want to show you two other implementations of the 6 that I wrote that I think are interesting and will have something to tell you. One is there's a tool called Pandas. Pandas, they call it a data frame tool. That's like a spreadsheet, except you can't put formulas in the cells, only values. But you can run formulas on the values. So this is a lot of comments, but it's actually pretty easy, and I'm going to explain what I did. First, I've got that input file, which I saved as day1.input. The separator in that file was white space. It was all numbers and no headers. So I said that there were no headers. And I wanted to name the columns left and right. PD is my name for pandas. I import it as PD. And read CSV creates a brand new data frame. So remember, a data frame is like a spreadsheet. This data frame is 2 columns wide. One of those columns is named left, the other one is called right. And I happen to know that there are 1,000 rows in the data that you're given. So it's 1,000 by 2. And because I gave the columns names that happen to be valid Python identifiers, I don't have to access them like it's an array or a dictionary. I can just say my data frame, the left column, gets what the left column was, sort those values. And when I say ignore index, essentially that's saying sort only the left column. That in combination with me just naming left here. So this, I sort both columns, and then all in one statement, I make a brand new column in the data frame. So this is a third column named distance, and distance is the left column minus the right column, the absolute value. Now this looks like it works on just one cell at a time, but because I used the column name instead of a specific row in the column, it works on the entire data frame at once. It solves the whole problem in one step. And all I have to do is take that distance column and extract the sum. The same with similarity. Right counts is essentially a dictionary. Right is a column, so that means it's basically a list. Value counts builds a dictionary in exactly the way counter does. And here I build a similarity column by applying the map function to the list and fetching out the number of times that left value appears in the right. And then, just like before, all I have to do is take that new column I made and find the sum. In my opinion, except for having to know pandas, I think this is the simplest solution. It uses, I forget what you actually call it when you work on an entire array at once, but it uses the notion of working on an entire array at once to solve the problem. So I really like the pandas solution. The Rust solution is very complicated. If Rust interests you, I put lots of comments in. You should look at the Rust solution to see what I did, because I think my solution is interesting and okay. It was one of my first Rust programs, but I think the last thing I want to show you is the answer in Lua. Lua is a very simple language. I tried to write it the same way that the Lua book formatted things. I don't know if that's good. I don't like this space between the function name and the parentheses. But I will say a couple of things here about Lua. First, Lua only has one data structure. It's called a table. It's defined with curly braces. It can act like a list. It can act like a dictionary. It's one-dimensional, like a pandas series or a Python list. It can have keys or not. And if you want it to be a list, then the keys are the values 1 through n. Lua is 1-based, not 0-based. So if you want to get out the first element, it's element number 1. The next place to put a value in the left list is The pound sign is the length of operator. So the next open spot in this list is the length of the left list plus 1. So this is me reading in the entire file, one line at a time. IORead NN gives me 2 integers, and it returns those 2 values into left val and right val. If either of those aren't true, I must be out of file and I'm done. I can break out of this loop. But if I got numbers, add them to my lists. At the end of the function, return the 2 lists. And then you can see that the 2 other functions that I wrote are just like the Python functions. Sort the lists, have a total distance that I'm adding up, do the subtraction, get the absolute value, add it into the total distance, return the total distance at the end. Same for similarity score. I do have to use this special thing called iPairs. iPairs is an iterator over a table, and it will return a pair of values where one is the key and one is the value in the dictionary. If it's a list, that key is going to be 1 through n. If it's a dictionary, then that key might be anything. So this is exactly the same as me building the counter dictionary in Python. And then this loop is exactly what I did in the Python code. In the Lua, I didn't know how to, I didn't want to think about it too hard. I wrote the tests using the test data and ran that and proved that it worked. And I wrote essentially what is a main function. Lua code doesn't have main, but it reads the 2 lists and calls each of the functions and prints out the results. And at the very end of the whole script, I call that main function that does the work. So this is Lua, the language that is embedded in everything. I think it's interesting. Every solution that I committed and checked into this repo runs, will run with the test data, will run with your data, will produce an answer, and has README files that say how to run it. I feel like I've already spoken too much, but let me now open it up to questions. If you guys, if any of you have questions about any of the stuff I just talked about.
Nobody.
I'd say I thought it was really cool. I love the Python example that uses the counter. It's a funny little built-in object that's like a perfect example of Python's import anti-gravity. It's just like
Hmm.
import the solution solver and use it. It's exactly what it's made for. Uh,
I totally agree with you. I Python is my favorite language. I'm really learning to appreciate Rust, but a Python program is so much shorter than a Rust program.
yeah,
The thing I'm proudest of and happiest about was my 4th Python example, the one where I did command line parsing in Python and I implemented the package in Rust. Um, that made me really happy. I had to figure out how to do that, um, and it was exciting when I got it to work.
yeah,
So
that is also really cool. I would love to learn into that, building Python modules in Rust and you know, keeping the part that needs to be efficient.
yeah. All right, I'm gonna stop sharing my screen and Jim can pick who's next.
Well, we had Dave kind of on deck, I think. Dave, you ready
I,
this
I
time?
think I think I'm ready now. So if
Okay.
I can figure out how to share my screen again. So here's a share button down at the bottom.
When a thing will come up and the very top left thing it shows you is
Is a
sharing your
screen.
entire screen, and
Uh,
everything else in the grid is specific windows.
so I click screen and now do I click share? I think I do.
You're
Okay.
doing
There you
it.
go.
It's all up.
That's your
So
whole screen.
this
Okay.
is my whole screen. Right. There we go.
All
So
right.
this is a Swift program, and in this upper panel here, I think that ought to be big enough to read. I have
Yep.
the data, my data. Anybody who does this, like Wolf said, will get a different set of data. I have that in a file, and then we have here on line 5, one of the, and I think it is this the way of reading the file in right now. And this changed from last year when we did this. The just substituting files didn't work. It makes you put in the encoding for the file, so you can't be just doing ASCII files anymore, I
Hmm.
guess. And the try question mark is kind of subverting the in case it doesn't run thing. You're supposed to catch that, but I'm not. So um, in Swift, you have to declare your variables, and you can do it either with a let keyword or a var keyword, and it makes you use let if you're never going to change it. If it's only going to get one value and it's not going to be changed, then you have to use let. And so on line 3 here, we set a variable, the file name, which we then did use, but we're never going to change the file name in this program, so we have to use let. On line 7, we've got left numbers and right numbers, but we have to use var there because we are going to change them. And I guess it makes a difference to it. Whether you're going to, if you use it and don't change it, then it doesn't have to do some extra stuff to it. So we then go through a loop here, and in back up in line 5, we set the variable contents to the contents of the file, and then we enumerated over them and come out with left numbers and right numbers, and turning them into integers as we go. Um, And in doing that, then we have to build these arrays. And on line 15 and on line 18, we're appending the left number to the left numbers array and the right numbers to the right numbers array. And we now, after that, have the numbers that are part of this file in the right numbers and left numbers arrays. So the next thing I did with it is I sorted them, which is just a method on the arrays. And for the first part of the problem, um, I did a loop, and um, this is a one of the ways to do a loop in Swift for a variable index, and the way it's through from zero because it's a zero-based system like most are to the line count -1 because it's a zero-based system, adding up or first of all in there calculating the difference, the absolute value of the difference between them, and then adding up the total diff, um, which we had defined on line 27, and printing that out. And so if we run that, although this will run the other parts, it came out with what my number is, and that was right. It should be that number. It's your number would be different. I guess anybody who did this, their number is different. Very clever. He did it that way. So then we have part two, which is where you go through the two lists and you to find out if how many times one is in the other and add that all up. And so the first time I did it, I thought I would do it this way intentionally. It's kind of the brute force method. For everything in the line count, I went through the first index and then went through the left index and went through the right index all the way through. And if the numbers were equal, I added up the match count. And the similarity score is well, see, I didn't even, then I just added up the similarity score and printed that out and thought that, that this is obviously an inefficient way to do it because we're going through 1,000 times every time, the lists are 1,000 long. If they were 12 million long, this might be a problem. And it turns out that if you can see down in the where I ran it here, the brute force method took 0.2 of a second.
It actually looped through that second array a million times, right?
Yeah, right.
Yeah,
And it did it
1,000
on this
times
computer.
1,000.
It did it in 0.2 of a second.
Yeah,
So you might think if you had never done it differently that is you might not even notice and know to optimize it. And that's one of the theories actually in programming these days is don't prematurely optimize code. Maybe you'll never need to do it and it'll be just fine. But I knew that was going to be inefficient. So I did it a second time, and this time I just went through it using the sorted lists. I went through and I stepped through the right side, resetting the starting point every time it got bigger. We were by it because you're not going to find any more. And then starting the next time where we had left off because you know that there'll be less and you don't have to do them. And when you do that, you can see in the second line there, it took 0.00072 seconds. So that's that's faster. But is that significant? I don't know. If we were done with this problem and only going to do it once and move on to something else, no, it took 0.2 of a second. You wouldn't even know. If that's inside a file system or something like that, it could easily be a big deal. But even there, the Swiss system has a dictionary mechanism, and so I thought, well, maybe we'll see how much longer it takes to build a dictionary out of this, and go through and do it by building a dictionary, and with their value there is the index into it, and the value is the count of them in there. And see how fast, how much longer it would take to go through all the mechanism of building the dictionary and then using that. And turns out that when I did it that way, it took about half as long. I for some reason, it just seemed like bouncing through it on my own would certainly be a little faster than building a whole dictionary out of it, but it wasn't. Now, I think Wolf, you had a thing where it would just build that, Python would just build that automatically for you. And there might be one of those in Swift. I don't know. I didn't even think about that to look for it until you started mentioning it. But it turns out
mine was a dictionary just like yours.
Pardon?
Mine was a dictionary just like yours.
Right, but I had to build mine manually, so to speak. I had to go through and build it. And you could just use one line, and it seemed like Python built it for you. Anyhow, I was surprised that it came out and it was, in the order of half as long to do it,
Sure.
to go through the trouble of building a dictionary and
Yeah,
doing it that way. That kind of surprised me.
that's pretty good. That's pretty good. So extra credit points go to Dave for solving the part 2 3 separate times.
Yeah, this came out. I've sort of become obsessed with how fast computers have gotten, and
Yeah,
the little computer sitting on my desktop or on my table here, and it does it
that's
does
pretty
it pretty
cool.
good.
Yeah. All right. Any questions, or should we move on to the next person? No questions. All right. Well, thank you, Dave. That was really
So
good.
I need to stop sharing my
Yes, you do.
screen.
And there
Okay,
you go.
that should do it.
So, Jim Peterson, did you want to show your solution? You did Python, right?
Yes, I did. I
You
can
want
do
to give
that.
us a quick look at it?
All right. Okay. Um, you see that all right?
Oh, yeah, I see it.
Okay. Oop. All right. I was trying to turn on my video. I lost the screen here. The Zoom screen here. Oh, here it is.
It's
I
there
think.
somewhere.
There it is. Okay. All right. So I've got part 1A and part 1B here side by side so you can see how they compare. The first parts here are the same in both cases. And I used Python as a practitioner might use it to process their data, just kind of quick and dirty programming. And so what I'm doing here is I set two arrays for the first and second columns, zero them out first. And then I go for each line in the standard in, and I split on the white space, and I append the element 0 to the X array and append the first element or element number 1 to the Y array. And then after I've done all those, I sort both because, as we've seen, that's the key to solving this part of the challenge is to sort both. So that's the left and the right are both the same there. And then in the first, the 1A, part 1A, we start with a difference of 0, and then just simply go through like Wolf did, take the zip of the two arrays, and that gives you an A and B for each line. Well, for each line basically in the original standard in. There's my debugging statement there. And then I just add the absolute value of the two to the difference and print it out. And over here, I did a double loop here, and I got to start with a similarity value of 0. And then for each A in the first list, I'm going to be counting how many there are. I set it to 0, and I look through the B array, which is also sorted. So we can stop, as was mentioned, Dave mentioned, you can stop when you get to a value that's where B is greater than A. You can break out of that to save some computation time. And if the two are equal, then I increment the count. And then here is a debugging statement. And add that A times the count that was achieved here, and incrementing that, adding it to the similarity and printing it out.
It's nice and concise. I like that.
Yeah, I was kind of using it like the engineers I used to work with at work. They would throw something together in Excel. So this is, just kind of a thing to throw together to process your data the way you need to.
Sure.
Mhm.
Sure. I might have added another break after line 28 because you're done once it's equal, right? So yeah, that line. If you just put a
Okay.
break on the, if you put another break on the next line, because you're done. No point in going to the, iterating through the next
No, there
item.
can be repeats in the right list.
Oh, can there?
That's true. Yeah. Yeah. Each time through
Well,
here,
never mind then.
you're incrementing the count. So like if you have
Okay.
3 of these, you have to
Yeah.
increment twice here to
Okay.
get a
Never
count
mind.
of 3. Yeah.
Okay. Never mind.
But your code is nice and tight. I
I like
feel
that.
like it's smaller than mine.
Well,
Yeah.
if yours was broken up into functions or subroutines to do
Hmm.
the work, and he's got it all in line. This is more the way I would write it,
Yeah.
all in line like that, because it's a quick and dirty program, right?
Yeah. And Jim, I know you're going to be doing Perl, and that's how we used to
Yeah,
use Perl at work too, where you would just do a
yeah,
quick and dirty thing like this.
yeah, yeah. That's nice. I really like it.
Thank you.
Yeah, good
Any
work.
Yeah.
any,
Okay.
questions?
Questions? No.
All
Okay.
right.
Uh, let's see. Mark, did you say you had one in Bash?
Yeah, I'd
You
like
want to
to,
show us real quick?
yeah.
Jim challenged me to write it in Bash, and I thought about it and decided not to.
Yeah.
Can you see my terminal here?
Yes,
see it.
and the size is good.
So I saved the file to the list to a file named list.txt using awk.
Ah, yeah.
By putting xargs in it, awk made me one big long string called left number.
Nice.
And
Nice.
I did the same thing for column 2 for the right numbers.
Right.
I did a little bit of error checking because if the lists don't have the same number, then your answer
Right.
can't possibly be right. And then TR has I can throw that through sort, and I can now get a list in numerical order.
So you're translating the spaces in between the items into new lines.
Exactly, so that it's
Yeah.
a list
Nice.
instead of one big long string.
Nice.
Set my variable, and then if I use this little @ sign here in my for loop, I can go through. I might have been a little bit more efficient and just did ABS here, but for some reason I was checking if it was negative or not.
Sure.
Then add it to my total distance and print it out.
There you go.
That's
That's
I can't understand Python and Rust and all this other
sure.
stuff. I gravitate
Right.
towards Bash because
Well,
in my world I can do everything in Bash. It seems
that's the tool you have that you use. That's good.
You're using the Unix philosophy of
Yeah.
scripting
Yes.
it and using you got
Yeah.
TR and sort there.
And awk and yeah, and
Yeah.
that's how you would do it. You could implement it in pure Bash, but you have to work pretty hard to do it. This is the way I would do it if I were in a pinch and somebody said, "Here, I need this real quick." This is a good way to do it.
Awk has got so
This
many
is
tricks
nice
in it.
Bash code.
Yeah. Yeah, I like it.
There's stuff in here I haven't seen before. In your right after the comment, calculate the total distance by summing absolute differences, where you say bang, sorted left, square brackets, @ sign. I've never seen square brackets, @ sign. That's new to me.
I think that's like
Yeah.
the array, the position in the
Yeah.
that picks which one that I'm doing.
Huh.
Yeah, I'm
Never
learning
the-
stuff about Bash all the time. I
Yeah.
know the punctuation
Wow.
in Bash. I still have not mastered.
Yeah. There's a lot to Bash, but it's pretty good. Thank you. So Justin, did you have yours?
Yeah, I can do mine.
Okay. Let's see what you
Yeah.
got.
I am pretty excited to see Zig code. I have
Yeah.
never seen Zig.
Yeah, this is maybe a little different than everybody else's. Uh, Definitely not short and concise. Uh, but yeah, so I hope you guys can see. It's just
I
in
see it.
Firefox window here. So yeah, I'm just learning a little bit about Zig right now. I'm like, it's a stretch to say that I'm learning Zig. I'm learning, a little bit about it and how
You're
to do some
muddling your
things.
way through it. Yeah.
Yeah. But yeah, it's really cool and interesting, actually. I really like some of the simplicity. It's not maybe as simple as like Lua, but of course it provides a lot more. Um, but yeah, let me walk through some of it and we can learn a little bit about it together here. Um, Zig does have a standard library, and you can use this global import function to get that. And now I also want to look at the file system. There's some methods there. I'm going to make an array list. So I need to grab that from there. And also going to print some stuff to the console. I grab print from standard debug.print. And then what you'll see here is most of this is just in this main function here. It's a public function main. In Zig, we return types and error types. This means that this is going to return void or an error, perhaps, but hopefully not. And we'll see. I think we've got another use of that bang in here. We'll see later. That you might specify your error type here, and then that is, helping you handle that explicitly. And that's really what Zig is about, is contrary to Rust, it's not memory safe. It's a lot more like C. There's no classes. But instead of like enforcing memory safety like Rust does, what it does is it gives you allocators. And so on the standard library, you can manually allocate memory on the heap. This one here is the general purpose allocator, which is really good for debugging, and it does a lot of safety for you and helps you kind of check some issues just in case. Um, you know, it allows you to be a little imprecise in that way. And then the very next line here is another unique thing in Zig. Whenever we are allocating memory, we need to clean up after ourselves. And so Zig has a keyword defer. And so what that does is that says in this scope, we want to do, we want to do this deinitialization, but we don't want to do it until the end of the scope. And so, yeah, you just defer it to the end of the scope, but you get to, define that right here where you're also initializing the memory. So it really helps you kind of make sure you're keeping that together. It's like really encouraging tight management of that. So you don't, oh, maybe I'll do it later. You can do it right there, and it pushes it all the way to the end of the scope. But yeah, and then we create this const allocator here. And so this is like the allocator struct that helps us create more memory. There's var and const. Vars can change, consts do not. And then yeah, so we're going to use those that allocator and create some more vars. We're going to get our left numbers. That's an signed integer, 64-bit array list, and we have to initialize it with the allocator explicitly. And again, we defer it to deinitialization. So we know that when the scope exit, we are cleaning up the memory. And of course, the same exact thing for the write list because they're identical. And now here we're finally getting to open a file. I liked all the standard input usage in Python that we saw. And I'm sure we could do this in Zig, but this is an example of things to do. So we're going to open a file. And so yeah, we use that file system component of the standard library, and in the current working directory, I'm looking for a file. I put it in an input folder, so redundant there. And we will try to catch any error. And if there is an error, we'll use that print to, print out our error and also return that in the main function here so that we know that we're not going to move on if there's no input file. And yeah, so this is sometimes confusingly, I think sometimes people relate this to, yeah, when you're calling this function, you can either go left or right. If you're going right, you're catching the error and then handling it. If you're going left, that means you got the value that you wanted, and you're, storing that in your file constant here. No, yeah, very explicit at every turn. We have to manage each error all the time. And of course, here, since we are allocating memory to that file, we have to close it eventually. And so we just say right here, right now, at the end, we want to close it.
Can I ask you a question?
Sure.
I keep seeing dot curly braces.
Yeah, that's a good one. So yeah, like up here, and I think there's one more down there. We have this dot curly brace. This is a anonymous struct. And it's basically the convention when we want to, send some configuration initialization data to this method, whatever we're doing. You do that in an anonymous struct, and this is like, the default empty anonymous struct. And that is also, of course, why it has more curly brackets at the end, is that's how we define a struct, and that's what the general purpose allocator is. And then, yeah, right down here, we are also sending an empty anonymous struct to this open file method so that, we could specify other parameters if we needed to. I believe that's where you would specify the mode that you're opening the file in. Here, in this case, the default, as always, is read. So, we don't really need to specify that here. Yeah, and then we, of course, we're reading a file manually. We're making a buffer. We get that file reader and pass that through the standard IO buffer reader to create our buffer reader. And then also get a variable here that we can then stream from that reader into. And, set a kilobyte aside of unsigned 8-bit integer to this buffer. Keep track of our line number with a line number variable that will increment. Usize is like unsigned int of your architecture. I'm on 64-bit ARM, so that's a 64-bit int. And yeah, now that we have some of those blocks of memory in place, we can now actually use that stream and read until delimiter or EOF, and we can insert whatever delimiter you want then. And go through each line by line. And first we do a little bit to make sure we get a line. Is there actually a line there? And then we want to make sure that there is something on that line. And of course, what if we had empty lines? Yeah, we want to make sure that we're kind of manually handling that. And then we can parse each number. Grab the string. Here we are using that iter. And if we're successful, that data goes into the left here, in this case, literally the left string value. Or we can handle an error if that produces an error and handle that right there and continue. And pretty much the same thing for the int parsing. We can use the standard library parse int, pass it that string. We want it in base 10. I'm sure that's what the radix is. Yeah. And of course, catch an error just in case that's not something that we can parse, and append it to our list. And then, of course, do the same exact thing with the right. Yeah, and now that we've got we have both right numbers and left numbers, which were these arrays that we made up here. Those exist outside of this while block. Once that closes, that's fine. If we had any error, we'd print that out. And if they are empty, we have a different error case that we handle. Say, oh, there's no number pairs in here. And then, error or move on. Yes, so we even print a success message here. And another interesting feature is Zig is it has all these has like anonymous blocks as well. So you can just create an anonymous scope where this variable exists right here and right now, and then outside of the scope it does not again. Just like a function that you might, but you can just do that in this little tight loop to segment your code. This I did it, as a convenient way to do part 1 and part 2. But yeah, in part 1, we grab those left numbers into a variable that we can then sort, of course. So this is our sorted left and our sorted right. And then this is our sort function. We pass each of those items into it and sort it ascending. Yeah, of course, at each point in time, reminding the system that this is exactly the size that needs to be. This is how much space you have for it every step of the way. And so, yeah, what are we going to do? We're going to calculate the total distance. It was the sum of the absolute value of the difference there. And it's funny, I was thinking about the left and right explanation that I saw a lot. So, yeah, if left is bigger than right, left minus right, else right minus left, instead of ABS. Of course, there's an ABS method, but, it's just same thing. This is an example of, there's no ternary operator because you can just write an if-else expression. Were you going to ask a question?
No. I'm surprised it doesn't have the ternary operator.
Yeah, no, it's very Spartan in operators. It's got the basics. It does not even have a power operator.
Wow.
So in the standard math library, there's a power function, but yeah, it's add, subtract, multiply, and divide, and that's it. And also, on that note, Zig does not allow any operator overriding. If you are doing something with an operator, that is exactly what that is. There's no tricks to pull here. It's secretly calling a function. No, all function calls look like function call, or method calls look like method calls, and that's all there is to it. No funny business like you might find in Python
Is
or other places.
Zig like Rust? Rust also doesn't have a ternary operator because all things that you would have thought were statements, like ifs or loops or matches, any of those things, all of those are actually expressions. If you put a semicolon at the end of them, they act like a statement. If you don't, they return a value to whatever's just outside them. Is that how Zig works?
Yes, I think at least softly I'd confirm is my understanding. And the syntax is a little different here. We have, an if statement that's, curly brackets if you're doing a statement. But yeah, it can just be an expression if you don't have those curly brackets, which is nice. And you don't need a ternary operator. This is, pretty similar to how you might do it in Python, just a little different. In Python, you put the truth value first, And then your if then condition else. But yeah, it's so weird because it's very, very different than Python, of course. But I do like some of the similarities, even just superficially, the snake casing, that is the standard there. And yeah, just some little parts of it here and there felt kind of familiar in a way. And yeah, no, I also just love the simplicity so far. I really appreciate that. Um, but yeah, and so yeah, then we got that total distance and printed that out. For the similarity score, of course, working with those same um, left numbers and right numbers that we got in the file or in the block where we were reading the file. We used them here. We made copies, right? And now here we will use them also. Um, and we'll create a hash map just like everybody else, a little different because we have to tell it exactly what it is, our index and our keys and our values, and use that allocator again to get the memory for that. And then, of course, so we don't forget, remember to deinitialize that and we defer that until later. Uh, and then yeah, we loop over our items here to get the number that we want. And this get or put gives us this const. It's like a struct that has a pointer to the value in the hash map, to the entry in the hash map. So we call it entry. And so it also has this value. I like that. It's a struct. So we have the pointer to the value. So that's entry.value pointer. And then we also have this struct member found existing, a bool that tells us what happened when we did get or put. When we did get or put, we generated this struct, and either the element in the dictionary already existed or it did not. And so if found existing is false, we do not found existing. If you did not find it, then you need to add it manually and set it to 0. And then otherwise we increment that value pointer and loop around. So yeah, I thought that was pretty interesting. I liked that the struct that you get from get or put. I thought that was kind of cool. Yeah, that we do. I did a little bit of logging here, so you could actually kind of see the frequencies and debug. That's a style I often take, especially with something like this. So you have to be so verbose anyway. You might as well like really detail everything you're doing so you can easily debug it. And then, yeah, calculate the similarity score. Another assigned integer, 64-bit. And then, yeah, we're doing the product of the sums. Is that right? Or was it the sum of the products? That's right, sum of the products. Uh, and then that's your similarity score. So yeah, that worked pretty great for me. We do a little bit of this printing with a value in it. We did that before too, but I forgot to point that out. Nice and simple. One of the other cool things is it lets you build in little test blocks by default. Testing is built in the language. So we created a test, sample input. We can give it like a string name with spaces in it, and set up different parts of that test, just like I did the different parts separately. Um, I used the data from the example, and then yeah, tested the methods that we have there. And yeah, we do this try testing expect equal to. We know the expected results, and we compare that to the total that we calculated. And same for part 2. But of course, part 2 is a little different. In here, I learned about this arena allocator, and it's so you can write your own allocators. And part of all of that is so that you make the code more cross-platform, right? You can easily swap out allocators as needed. But in this case, we have another kind of generic allocator, an arena allocator that is particularly efficient for allocating a lot of little things that you'll probably just deallocate all at once because that's how its deinitializer works. And yeah, and it uses like a small amount of memory for each little part. So we have our own special allocator just for that, for this hash map. And yeah, again, here we're creating our frequency map, deinitializing it when we're done with it, and doing basically the same thing as we did in part two, getting the sum of the products and displaying the similarity score. And then here we're actually just testing to see if it's equal to the value they said it would be. So
Very nice.
yeah, lots of fun little things in here. It's a really interesting language. I really like, I got excited about Rust when I learned about that a few years ago, or started to. I'm still not an expert or anything, but I'm also really excited about this. It's just a very different approach, and I think it's pretty cool. But yeah, thanks for letting me share.
Well, thanks for putting the time in. I appreciate that.
Absolutely.
It's really cool.
Yeah, this actually surprised me. Zig is nothing like what I thought it was going to be. It's very interesting. Did
Yeah.
you do any timings?
I didn't. I wanted to because yeah, like my understanding is we can get pretty efficient here, and that really wasn't my goal in the structure clearly. But yeah, this should be very fast, or at least tunable to the platform you need to run it on, and can be as fast as it needs to be for that platform. So yeah, that would be pretty valuable.
Yeah, pretty cool. Thank you.
What
Yeah.
about, I was going to ask what the star property is, for example, on line 104.
Let me go down. 104. Yeah, so that is the pointer.
You're dereferencing a pointer?
Yeah, we're dereferencing the
Okay.
pointer. The entry is a struct that has
A little
this
bit like, yeah.
pointer that
Yeah.
points to memory in in the right frequency.
A little bit like C.
Yeah.
Yeah, cool.
Yeah.
Zig seems like C with try-catch blocks.
Yeah.
Yeah, well,
Yeah.
the try and catch is a little bit different. Try is to propagate errors, and catch is to handle them right then and there. So you kind of use them separately. But yeah,
Sure.
yeah, it is kind of like that, where it's like, okay, kind of like C, but you've got error types built in, which I think is really cool too. It's a really interesting modern development.
Yeah, like you can throw a certain type of an error and catch it.
That way, you're the system, the API that is producing this error kind of has to map that out very explicitly, and it can explicitly handle all of it properly. So yeah,
very good.
Cool stuff.
Thank you. Yeah, thank you.
Thank you.
No problem.
Yeah. Let's see. Joe, are you ready? You want to share yours?
Yes, let's do some Haskell.
Is there anybody else?
2.5 weeks.
Is there anybody else that has a solution they want to show? Because I'll hold mine to the end. I don't know if anybody else had one. You might be it. All right. Well, if you have one, send a chat message so we'll know while Joe is showing off his cool solution.
Well, let's see. Yes. Mac and its security and privacy. Yeah, apparently it didn't like that I was because it was sharing in a recorded session. Okay, let's see if it happens later if I gotta quit. If I can't share, then I'm just gonna switch computers. Oh no, it's good.
Okay, good.
Let's see, there we go. We got some Haskell up?
Yeah,
Yep.
yeah.
There it is.
All right, I'm not gonna actually talk about this. It was an interesting move towards it. I couldn't figure out how to split the lines to get each value out separate. So It was interesting. It got me started down the path because I didn't know any Haskell before starting.
Yeah, but our version 2 is the cool one.
Yeah, that's the one that has all the important stuff in it. It was interesting along the way. I'm not going to talk about every line, but some things that I think are interesting. The language statement basically defines which version of Haskell and the available things you're going to support. So when you put that in, every compiler will go, okay, you only get these things. So you can only have the latest compiler, but always be backwards compatible, which was interesting. So you can compile stuff that was written for an older language variant on your modern compiler. Importing things, if you wanted a name, it was just in a parentheses there. I did have to import this map because it was being, it was a little wonky trying to get the map function in the standard library to work the way I wanted it to. I like getting arguments and feeding in command line arguments, so I went through the trouble to do that. One of the things that is a little bit odd is that variables once declared are immutable, except for lists, and you can add to them, but they're very much a function is going to take some arguments and return something, and the only thing that can change is the return.
So it's FP, functional programming.
Yeah, functional. It's functional programming. It doesn't require parentheses unless it's ambiguous about which should happen first. A lot of them, so like here, that's the function read file, but I didn't have to, declare the parentheses on there. Ordering of them, like this is two different functions. So in my column lines, I do a convert lines function that I declared on lines in file contents. You can see the convert lines function is down here with a type signature. I'm just going to get an input list as the name of that input argument. And then I create the first list basically by doing a list comprehension to read in X out of split it in words, which is space delimited. And then the prelude map is what comes in the standard library. And then pass that off to basically a string slicing. I want the first element and then whatever's left. Don't care what it is. And then I'm only actually using X. Read will turn it into an integer if it's an integer. And I wanted it sorted, so the first list gets sorted in there. Same thing with the second list, except I take the XS, but only the first element of it by using head.
The second
So
one.
in the list comprehension, it's what you want the list items to be, and then the pipe symbol, and then how you're going to get the list items out of whatever you're generating. Then I zip them together so that I have only one return value, which is basically a tuple of lists. And then once there, I just sum up the absolute value. You can actually extract the tuple. You see here, column lines is the tuple of lists. You could extract them into XY and then use those over here in the list creation. And then some will just sum up a list items. So that was pretty easy. The other one, again, the only way I found to get my read function wouldn't work outside of this convert lines function. So I couldn't get it to actually give me a list of integers outside of that. So all I did was I unzipped the list into a new variable. And then I had to create a first list function and a second list function to actually get each list separately. All it does is pass in that tuple of lists, returns a single list. I want the X one. So if you get a tuple of lists, I don't care what the second thing is. I just want the first thing. And in this one, I don't care what the first thing is. Just give me the second thing. And once I've got that, then this is just a big list comprehension to get the similarity. And if X is going to get the first list. So that's pretty simple. Generate the X's, with the first list. Then everything else on the left is creating each list element. So I take X multiplied by the results of all these functions chained together. Take the second list, and filter it using, if the target is the same as X, okay, then I want to use it. And then you get X times that value, the length of that value. So it filters, gives you however many of them are in there, basically a list of elements. And then the length just tells you the length of that list. So there were 14 of them, multiply X times 14. The other thing was with a print function, it only deals with strings. If you want to see anything else like a value, you have to use show to get it to transition that into a string. A lot of so I learned it in 2.5 weeks. Hello world, basically now. The interesting thing is a lot of the documentation will tell you not to use list comprehension because it can be confusing. And although I agree, I'm used to using list comprehension in Python, so it seems intuitive to me to use list comprehension. It was easier to me to see, oh yeah, I'm gonna get a new list. I'm gonna get values X from the first list and then do whatever transformation on the left side of that pipe symbol to get the items I want. And then I just want to sum up the items in that list. So that was one of the interesting things I felt on it, is that, yeah, it's harder to use variables because there's no mutability. And then it is there really is great list comprehension out of it. You can see that, oh, I guess I didn't actually use. Did I not use them? I guess not. Well, I don't even know that I use this map function that I imported. Well,
yeah, you do. Line 36.
On 36. Oh, yeah, right. No, that's Prelude map. That's what comes in the standard library.
Oh, okay.
Yeah, I as I said, I'm going through a lot of the documentation and searching and finding things.
Sure.
And I don't think that's required because I'm not using that. And I didn't use nub after the fact. That's a way to get the first element of a list. You just get the nub of it. I just want the little bit.
Okay.
So the big things were the language declaration saying this is going to be compiled in whatever version you want. And then like I said, list comprehensions, they're very powerful, but I could see where some people think that that's a little illegible, especially if you do like most of them will just use like X and Y. Okay, I'll use X, but right here you see I use target, which basically says filter out of the second list the target. That's what goes into here. Is that equal to X? I can see if you don't use good variable names in your list comprehension that it can get very unreadable.
Right. But that's very cool.
Yeah, super interesting learn. Go ahead.
Yeah.
Question. I'm not familiar with this zip command. It sounds like different programming languages.
I think
25 words or less.
Well. Zip just takes a list and it takes each element in a list and zips it up into a tuple.
Yeah.
The way I used it, it zips 2 lists into a tuple, single tuple. So it just basically takes 2 elements and zips them into a tuple.
What is a tuple?
It's a
pair of elements.
2 values kept together.
Yeah.
It's like a list, but it's a finite number of items.
You have an item from a value from the first list and a value from the second list put together.
Like if my first list had the value of 1 and my second list had a value of 2, I would end up with 1 space 2 in a variable.
Or 1 comma 2 or yeah,
1 comma 2. And you could do that, and that's what it's designed to do, is just like take 2 lists, put them together with each of them paired together. So your first item's paired with the first item in the second list. And it just keeps them together. A coordinate pair would be a tuple. XY, that's a tuple. Because they make no sense without the other one.
Thank you.
Yeah, think of the coordinates, right? X and Y.
You can actually have multiple you can have 3-element tuples and 4-element tuples, but they're finite. You can't have more than the elements you declare them as.
It's like a unique array. It has to be one of the items.
I don't know that I'd agree.
Yeah,
It's a
unique isn't part
finite
of it.
array.
Like instead of like an object, instead of like a
Yeah.
hash map or dictionary,
Yeah,
it's a list.
Yeah, but
It's
it's
a list.
finite. There's only the number of elements you declare it.
yeah. In his case, it's a list with pairs of items. Each pair is a tuple.
Actually, it's just a single tuple with 2 lists as the elements.
Oh, is it?
It is.
Okay. Okay. It's inside out of the way I think.
Yes, it is.
Yeah.
But that's what's neat about this Haskell implementation is that it sort of acts like the Pandas implementation that I showed, in that you've got it operate in some of the lines, you have it operating on the entire list at the same time.
Well, it's lazy evaluation in Haskell. So
Yeah.
even though it looks like it's operating on the entire list, it's only taking each line lazily.
Yeah. But it's a
So like
functional
up here, where you
programming
see
language.
column lines gets into this tuple XY. It's actually just taking the first line of each one, the first item for each list, and putting it in a tuple XY. And so it's lazy evaluation. It doesn't actually take the whole list. It only does it as it's asked for.
Yeah.
I see. You tricked me.
It's pretty cool.
I
Let's see,
don't
is there
know
any-
if he's actually in the meeting, if he's actually here, but I did just accept a Python pull request from another person who cared.
What was his name on that request?
They are here. If you want me to, I can share that. Let's see. Oh,
We're getting short
I
on
thought it
time.
was
too.
interesting myself. So let me share that, and they can talk about what they were thinking on there. Let's see. Python. Is that what you're talking about?
That
Yeah.
is what I'm talking about.
And I will hand it off to you.
I'm Zoe. I wrote this program today and I forgot to do part 2. Well, I didn't have enough
It's fine.
time to, because
Yeah.
I kind of just got this done in an hour before I came here. But I did part 1, and in this program, I started out by importing the data file, and I wanted to make it so that it would easily like just take the data in. So I grabbed the path that the file is currently in and added the file name to that to get the absolute path. And at the bottom, there is the entry point, and it first parses the data file. It will parse both columns into 2 lists and then return a tuple. And the tuple will then be unpacked into list 1 and list 2 of the entry point block. And then we will calculate the sum by passing in both lists to that calculation function. And we will go over each item, or I guess we'll actually iterate over the length of list 1, and both lists are the same length. So I just chose to iterate over the length of list 1. And I chose to calculate the minimum of both lists and then pop that item out of the list so that we would go on to the next minimum number of both lists. And I paired them, and to find the difference, I found the max of the pair, subtracted that from the minimum of the pair. So it's, I guess, I don't know, I thought it was really like clean to do that. It was a really nice way to get like an absolute value. I think Python has its own absolute function built in. Then I just add everything up to the sum and then I return it. And at the end, we print it out. And
You didn't realize we had a max and min function in Python of a tuple. Yeah, because see, there's another instance of that tuple. And then pair is that tuple with those two values in it.
Right.
What I found interesting with the pop, I had never seen that in Python before.
There are a few edge cases in this program since I wrote it pretty quickly. I think, well, I guess first as a possible way to improve it, it might be possible to turn that sort of popping expression into a generator, but maybe that would add a little unnecessary complexity. But when we read the data file up there in parse data, I would also like to add like a type check system where it'll check if each data point of both columns is actually an integer, because if it's not, it's going to fail up there. And if we scroll all the way to the top, there are a few other things that I'd like to improve about it, like a user-friendly error message if we try to open a file that doesn't exist. And also, while I was writing the program, I was creating a data file, and in Windows, it's a little difficult to create a text file. It's like, I have to right-click, add new, and there's no text, TXT dropdown. So I would just choose like a rich document, because that's available to me. So I would enter my data. However, it doesn't, it'll save the rich text document, and within the bytes that encode the file, it'll include that file type. So if I use a text editor to put in all the data, it will still be a rich text document. And when Python tries to read that, I think somehow I got into an error with that. I can't exactly remember what triggered the error, but
Something in the file.
yeah.
Yeah, it adds control codes in there.
Yeah.
I think it was how I was reading it. It was reading some sort of data of the rich text document, even though I had only entered all of the column data. But yeah, that's my program.
Very nice. Thank you. And thank you for submitting a pull request for us to add it, because the stuff stays out there. People, in the future can come and look at it. And
I really like that you use types. That's classy.
Yeah.
Yeah.
I love making everything like complete with types and method signatures.
Yeah, Dave and Mark, if you'd please send us your code, we can integrate it into our GitHub repo.
I'm not a GitHub guy.
We can put it in there for you.
I'll email you.
Okay, thank you. Anybody else before I do mine? We're getting kind of short on time here. All right, I think I'll go here. Let's see. Now it's my turn to figure out how to share, right? Let's see. I want to do
We're a technology group. Hello.
Yeah. Hello.
That's what I tell my
TV is hard. You should have seen how long it took me to get this TV on.
Yeah, that's the one I want.
Yep, there it is. Perl.
Yeah, the problem with Zoom is I can't see it. Okay, well, is this let me highlight. Is this the one you guys are seeing? Yeah, it is.
Yep.
Okay, good.
Looks
Okay,
good.
so this is my Perl. I did it in Perl, awk, SQL, and Vim9 script. We don't have enough time for me to show you all those. I want to show you the Perl because it's fast and simple. And I want to show you the SQL one because I think that's the cool one. So anyway, I don't think there's any surprises here. It's I think if you compared my solution with like Jim Peterson's solution, it's nearly the same thing. Only his was Python, mine's Perl. Here we read in the file. We get the file name from the first argument. You see, this is how you run it. You just run the Perl script with the file name as its argument. I create a couple of arrays to hold the columns. I open the file. If I fail to open it, I'll spit out an error message saying what happened. Then I loop through the file, splitting on a space, because remember the file is a number, some white space, and another number. So we split on that white space and put it into left and right. And then I push left onto my column 1 array, push right onto my column 2 array, and then I close file. So by the time I'm done here, I've got 2 arrays containing my values. Then, just like everybody else, I sort the first one, I sort the second one, then I loop through. Basically, I'm looping through the size of the first array. I know both arrays are the same size, and I'm just taking the absolute value of the item in the first array, subtract the item from the second array, take the absolute value, sum it, and print it out. So it's fairly simple. It'd only be a few lines of code if I didn't have all the comments in there, but I wanted to explain what it was doing. So that's part 1. Let me show you 1B. Again, starts up pretty much the same. We get the file, only instead of building 2 arrays the way that I did before, I open the file and I loop through every record in the file, splitting each record on white space, stuffing the values into $left and $right. I push $left onto the array, but for column 1, but column 2, I'm making a hash or dictionary. In fact, I defined it right up here in Perl. We call them a hash. I think in Python you call it a dictionary, right? So I'm looping through, and for everything in column 2, I'm checking to see if it's in my hash yet. If it is, then I increment the counter. If it's not in the hash, then I create it. I put it in the hash with a value of 1. Okay, and I close the file because I'm done with it. I set my sum at 0. Now I loop through column 1, the first array, and if it exists in column 2, I take the value of it. It was the count of entries in column 2, and I multiply it by the value of column 1, and I just add it to my sum, and I print it. So it's fairly simple. It's fast. It's using a hash, kind of like the way Dave was using a hash when he did it in Swift. I think a few other people used a dictionary as well. But that's it for Perl. If there's no questions about that, are there any questions? I can't see any hands raised or anything.
So a tuple is a 1-column hash, right?
To me, it's just a list with 2 items.
But can you
many items
have like 6 items in it?
No.
No?
Well, you could have a tuple with.
Is a
How are
2-item list.
Well, the way we're using it is. It could have more.
Is it?
Yeah.
Am I thinking enum?
Define this like an immutable.
Enum is something different, I think.
I think enum's a fixed count.
Depends on what language you're in. It depends on what language you're in.
Yeah, exactly. Right.
Yeah. Enum in Swift is different than an enum in C. And anyway, so that's solution 2. So let me get to the SQL one. Because that one, I've got it up over here. Hang on a second. Okay, let me bring it up. Okay, so here, what I did for SQL, since we've got this flat file containing these 2 columns of numbers, I created a temp table this solution will only work in Postgres, by the way, because it's using a few things that Postgres has that other databases don't. Anyway, I create a temporary table. I copy the data in. See, my table is called data. So I do a copy data from PSQL standard in. So I think up here I even show you, this is how you would run it. PSQL -f, that's the name of my script, and then redirect the data into it. Okay, so I copy the data in, and that populates my temporary table with those rows. And then this is where the magic happens, this whole thing. It's kind of neat because it's looping through the data twice. Once it does this select to get column 1. See, we're doing this regular expression where there's some number of digits, some white space, and then another set of digits. And we're taking the first value, so that's a capture group. We're taking this value, and that's what we're selecting, and we're sorting by that. Okay, and then we turn it into an array. And then we do the same thing to get the second value, only this time we're doing the second capture group in our select. And we're sorting, it's only producing one value, so we're sorting by 1. So I got these 2 arrays. Now they're, instead of one array or one table with 2 values in it, I've got these 2 arrays where each one of them has a value. And then unnest. I don't know if you guys are Postgres programmers, but unnest is awesome. I can take an array. In fact, in this case, I can take 2 arrays, and I can turn them into basically rows. And then I can select from that. That's what this is doing. And it's getting column 1 and column 2, subtracting them, getting the absolute value from this. And then I wrap that all up as a subquery, and I do a select sum where and that's bar. I'm summing the distance. That's this guy. I'm summing it, and I'm producing the result. So I'm just going to run it real quick. PSQL -f1a. I'll do the sample. You see it spits out value 11. If I do the regular data file, it spits out, this is my big number. You guys would get a different, because you'd have a different data file. Go back into it. Further down in the file, I sort of deconstructed what it was really doing. In fact, I can run this in PSQL line by line. So let's do this. PSQL, there's my database. And I'm just going to copy and paste these lines from another screen. If I can. So right now I don't have any database. I don't have any tables in my database. So I'm going to create my table. So now you can see I have a table. If I look at it, it's only got 1 column in its text. I'm going to suck in my data file with this. So now if I do a select star from data, there's my rows. All right. Now I want to get the first column. That's this. Right. I did a select regex replace data. So that gave me the value of the first column ordered. Right. It's this column here, but it's sorted. So it's 1, 2, 3, 3, 3, 4. I do the very same thing to get the second column. 3, 3, 3, 4, 5, 9. That's these guys up here. All right. Now I'll kind of step out 1 level and do this. You see, this created an array, and this created an array, and the select gave me both of those arrays. So there's my first array, and there's my second array. You guys still with me here? I go to the next
looks good.
step of the program, and I'm doing the unnest. And watch what this does. This gives me finally my two columns with their sorted contents. That's what this whole mess did. Then
A question, that order by one.
Yeah.
I've never seen
order by. Usually, most people would write order by, and then they'd name the column that they're sorting by. You can instead of naming the column, you can just put the ordinal number in of the column. In this case, it's column 1.
Why did you choose to use 1 instead of spelling out the column name?
Because my columns don't actually have names. When I'm doing this, this value, I could have done it if I had said after this, if I had said as col 1, gave it a name. But this column doesn't have a nice name on it because it's a expression.
Okay, I get it. Thank
you.
you.
So it's a kind of a shortcut. I can just say, give me the first column. And each one of them is only producing one column. So in both cases, I'm saying, give me the first column. And in the top one, it's the first capture group. In the second one, it's the second capture group. Okay. So I'm at the point now where I've got my array. I did my select, my unnest, and it gave me my rows with sorted columns, right? So now let's go back over here. Let me paste this. This is the next step. This is where we get the absolute value. So each one of these, like 1 minus 3 is 2. 1 minus 3 is minus 2, but we asked for the absolute value. So it's 2, right? 2 minus 3 is minus 1, but the absolute value. 3 minus 3 is 0, and so on. So that gives us all these rows with they're all positive, okay? Then finally, we do all that, and we added this sum. So we summed up all these values in the array. That gave us 11. And you can look at it. 2 plus 1 is 3, plus 1 is 4, plus 2 is 6, plus 5 is 11. So I really kind of liked the way this solution worked. It'll warp your mind if you're not careful. And let me show you the second one. There's a couple of steps here. In this case, I created a table called data. I copied the data into it. I created another table called columns. I insert into columns. I insert into these two columns, basically that array of columns that we did before, where we're getting the first column, the second column. In this case, we didn't have to sort them. Sorting wasn't important. Anyway, they get stuffed into this columns table. And then I just do my, I select column 1 times the number of times column 2 is found. The number of times column 2 is found in column 1. Right? So it's this times the frequency of this in column 2. And I get the sum of that. I'm not going to run it step by step like I did the other one because we just don't have time. But it works. It's PSQL minus F1B data sample gives 31, which is the correct answer. I can run it on the big file, and it's fast. Right. That gives me that number. So, questions? I know I moved kind of fast, but we're tight on time.
Can I just make a general concept kind of question here?
Sure.
So based on the associative law of addition, it doesn't matter what the order of the input is. So you don't need to sort them. If you take all the
for which one? For part A or part B?
Well, so I'm just looking at that concept where you take two columns, you take the difference of each of the numbers after they've been sorted. If you didn't sort them, the number would come out the same, I would think.
No, because you're adding and subtracting different numbers. if
Okay.
right, if let me scroll back. If these weren't sorted, you might be subtracting. If they're in no order at all, you're going to come up with a random value as your answer, right? Because in this case, we're subtracting 9 from 4. What
Sure.
if?
Okay, but if you
9 was-
added, all right, so if you added everything in column 1, 2, 3, 3, 3, 4, come up with that
Yeah.
number, then
You
add
look
up
at
everything.
3s and 4s, you can wipe those out. So then you get, yeah.
so you're saying add up all these first, and add up all
Yeah,
those first, and
well, if he says remove the
subtract
3s and
the answer
4s,
of that.
since they're the same on both sides. So it's 1, 2, which is 3, plus the 5
Plus
and
9.
9, which is 14. 14 minus 3, right? So that'd be 11.
11. Yep.
So
Got
what
one,
answer
Joe.
did you come up with?
I think the problem, Gib, is the rules are not just the difference between the two. The rules are calculating the trip
It might be like a
distance.
happy accident.
Okay, anyway, so I just thought I'd throw that out
I
there.
understand what you're saying.
That's crazy. Nice noticing that.
Yeah. Oh, I'd like. I'll play with it and see if we get the same answer. It seems like we won't, but
That would be like
uh,
canceling, like in like long division or something. You can cancel something on each side, right?
yeah.
Right, so go
Yeah.
ahead.
That's just for the first. That's part A of the problem. Part B, we don't sort them anyway. It's multiplying numbers by the frequency of time. The number of times they occur in the other list. So that wouldn't matter.
But you could do like a pre-check for numbers that are in both lists and just wipe all those out, and then you could do your calculation on like the remainder.
Well, I think if you take any group of numbers, it will work that way. But I don't think we probably don't have time to go over all that.
Yeah. Well, we've got the data in here. So let's try this. Select.
I didn't notice that until this one. We've done the same problem over and over.
You got an X in select there.
You're right. Let's see. That's not sum, actually. It's from what is my from data. Plus minus select sum col 2 from data. I need another parenthesis here.
You want a minus there, it's an equals.
Right.
There you go.
So you think if we sum up column 1 and then subtract the sum of column 2 from it, PSQL minus F1A. Oh, see, I can't exactly do that. It's not, these aren't coming from data. These are coming from this.
Just do from food instead of from
I'm sorry?
data. Just do from food.
Well, food doesn't exist down here. I have to actually put food.
Oh,
I
it
have to
just
put foo
appears
in here.
after. Oh, okay.
See, I can do that.
Yeah, right. I got it. It disappears after that context.
Yeah.
Yeah, yeah.
Oh, that's just past the.
let's see, does that work? Well, we're not doing absolute. Right? If I put ABS, all right, extra credit goes to Gib.
Something I learned in second grade finally is useful.
Yeah. That's pretty good. Finally helped you. So yes, we could do that. Although it seemed like there was something in the data that told us not to. I don't know. Anyway, that's
Well,
cool.
the good thing about designing it that way is you wouldn't have to do sorting, and so you wouldn't limit how much space you needed and stuff. You could just read the records in one at a time and do the calculation and keep a running difference and go through infinite number of
Yeah, you could do the whole thing in about 4 lines of code.
Make it dual threaded.
Or in Perl, you can do it all in 1 line of code, right? It would just look like line noise.
Yeah, it depends on how obtuse you want it to be.
Sure. All right, so we're like 10 minutes after our ending time, but that's all right. I had a lot of fun tonight. I hope you guys enjoyed this. Now if I can figure out how to stop sharing here.
Yeah, had a good time. We're probably going to get kicked out here any second now.
Yeah.
We'll see everybody later.
All right, we'll see you, Joe. Thanks for your input tonight. It was excellent.
Bye.
Yeah, bye.
Well, that was pretty good.
Yeah, it was pretty good.
Thanks to we got a lot of contributions to this too. That was really nice. I appreciate that. Let's see. Did we lost Dave, didn't we? Yeah, well, he's in Massachusetts skiing this week, so I think we interrupted his ski vacation. But it was great seeing you guys. I need to drop off, and I think when I do, because I started this meeting, it's going to kill it for everybody. But we'll see you all next month, April 8th, I think. And we'll send out an announcement and let you know.